Welcome to reading and writing TDMS files in MATLAB. This example shows how to inspect and read TDMS files into MATLAB, how a datastore can be used to analyze a collection of TDMS files, and finally, how to write the results of the analysis to a TDMS file and update its metadata. For this example, we have vibrational measurements of a rotating shaft recorded across multiple TDMS files for varying RPM. The goal is to read this dataset into MATLAB, apply algorithms that check for rotational imbalance, and to generate a status report in TDMS file format. On the rotating shaft, there are two displacement sensors labeled X and Y, which measure changes in distance between the machine's rotating element and its stationary frame. There is a key phase signal to provide a reference point in the machine's rotation, to correlate with other vibration signals, and to provide a simple means of measuring shaft rotational speed. Let's look at one of the measurement files. The TDMS info function provides an overview of the file. The channel is field lets you view the channel groups and channels in the file. Here, the pulse channel is the key phase signal. Sensor X and sensor Y are displacements measured from sensors X and Y respectively. Before reading the data into MATLAB, you need to find the time step with which the data is recorded. Using TDMS read prop, you can obtain the channel properties. The WF_increment property reflects the time step in seconds. Read the data using the TDMS read function, then plot the data. In the plot, observe the X and Y displacement sensors indicate a high vibration at the same frequency as the shaft rotation. The next step is to perform a frequency domain analysis on these signals, where the phase shift between the vibration sinusoidal peak and the phase reference pulse indicates where the machine is out of balance. Let's pass the data to a custom vibration analysis function. This function returns the rotation RPM along with a boolean that indicates whether the shaft is within the balance limits of that RPM. Now let's look at reading multiple files into MATLAB. MATLAB has the concept of a datastore, which allows you to iterate over a single large file or a collection of files that have the same layout. In this example, we use the TDMS datastore function to iterate over a collection of vibration measurements. The datastore read size parameter sets your iteration size. Here, we use a read size of file to iterate one file after another. The typical pattern to iterate through the datastore is to read data in a while loop until the end of the dataset. There are various functions in MATLAB that can be applied to a datastore. One such function is the transform. The transform function takes in a datastore and a function handle and returns a transformed datastore object. The function handle can be any operation that you want to apply to the dataset. In this case, we want to apply the webAnalyze function to each of the recorded TDMS files. We create a transform datastore iterator and run the same iteration while loop, but this time it accumulates the results of each file in the webRes variable. The results show the rotating shaft is unbalanced at 900 RPM. Let's write the results of the analysis to a new TDMS file called rotating_shaft_report.tdms. Observe the file now contains a default channel group and two channels which are named according to the table variable names. Let's read back the data to validate what was written. Here again, we see the imbalance at 900 RPM. Let's add a title to the new file. You can read and write metadata using the TDMS read prop and TDMS write prop functions respectively. A new TDMS file is created with default properties such as description, title, and author. Let's update the title of the file. You can also add custom properties using the same TDMS write prop function. Let's define the RPM channel units to be RPM. We need to specify the channel group name and channel name when calling TDMS write prop and read prop. Here again, you can see that a new TDMS file comes with the default channel properties such as description and unit underscore string. Let's update the unit underscore string value to RPM. Also note that a file, channel group, or channel must already exist when writing any of its properties. In this video, we showed how vibration measurements in a TDMS file can be inspected and read into MATLAB, how custom transformation functions can be applied to a datastore to analyze a collection of TDMS files, and how to write the results of the analysis to a new TDMS file and update its metadata. The TDMS read features are available starting in R2022A, and the write features are available starting in R2022B. Don't forget to consult MATLAB documentation to learn about other resources and functions for TDMS files.